Hi, welcome to my video on Lewis dot diagrams. It's super fun, super great, raving reviews, everyone loves it. So I'm just gonna go over and review what we did in class. First things first is we're gonna be doing these Lewis dot diagrams for compounds, but you have to be able to do them for elements before you can do them for compounds. So if I was gonna draw this Lewis dot diagram for carbon, for example, back in the day, we used to do it with this little imaginary box, like this was like our little training wheels. And so you would look at the valence electrons, which you have 4 valence electrons for carbon, and you have to put 1 on each side of the box before you can pair them up. So on the actual diagram without the imaginary box, it would look like this, 1 on each side. So for nitrogen, which has 5 valence electrons, I would do 1 on each side. But I need 5, that's only 4. Now I'm allowed to pair them because I have 1 on each side. So anyway, that's going to be really important today when we start bonding them. So if you don't know how to do that, maybe go look at my old video on that. Okay, the goal today is to bond atoms so they have 8 electrons, except for hydrogen can be happy with only 2 electrons. So we're just going to be putting some atoms together and trying to figure out a way to bond them so that they can all have 8. I like to use dots and X's instead of just dots, even though technically, it's a Lewis dot diagram. But I like to use dots for one element and X's for another element so that I know which electrons belong to who. And then if you have one dot and one X, you can make that into a line. And then one line would equal 2 electrons. So when you go back to check your work, then you can count and say, okay, every line is 2 electrons. Here's my tips and tricks. Number 1, use a pencil so you can erase or dry erase board. Use dots and X's if you think you might get confused on who belongs to who. My other recommendation, very important, and I see students do it all the time and then they get confused. Don't draw the lines first. Only replace dots with lines. If you go in and draw lines first to connect your element, then it can get really confusing on how many electrons you might need to draw, how many bonds you need. So I like to draw the dots first and then replace the dots with lines. And then put unpaired electrons towards other atoms. So that's going to make more sense when we do our first example. Our first example is going to be, we're going to do water, H2O. So I should have written that over here. But we're going to do H2O. We did this one in class, but I want to make sure we do the ones we did in class so that the students who weren't here can see it. I need to figure out my valence electrons first. That's my first step. So oxygen has 6 valence electrons. I'm going to put that right here so I remember. Hydrogen has 1 valence electron. And then I'm going to start drawing my dots around my elements. So for oxygen, I need 6. 1, 2, 3, 4, and now I can start pairing them on the sides of my imaginary box. But remember I said put unpaired electrons towards other atoms. So it's the unpaired electrons that are going to end up bonding. So if we want to bond something to hydrogen, then we want this electron by itself so it can bond. And if we want to bond it to this hydrogen, we want this electron by itself. So I'm going to put the paired ones on these sides of the box so that I can easily bond. Hydrogen has 1 valence electron, and like I said, I'm going to be doing X's for my other atom. So I'm going to do 1 X here, and the reason I'm putting it on this side is because it's in the direction of another atom I want to bond to. And then same here, 1 valence electron. There it is, and it's in this direction. And I can connect or pair up dots and X's and replace them with a line. So this dot and this X can now become one line. But there's still 2 electrons contained within this bond. There's still a dot and an X contained within this bond. And what that's saying is instead of oxygen just having 1, 2, 3, 4, 5, 6 electrons, now it's like hydrogen is saying, okay, I'm going to share this electron with you. So now it has 1, 2, 3, 4, 5, 6, 7. So that's why every line counts as 2. And we're trying to get oxygen to 8 electrons. So we're going to bond it to this hydrogen. A dot and an X can make a line. So there's a line, and then we want to check our work to make sure that we did it right. So 1, 2, 3, 4, 5, 6, 7, 8. So now we have 8 electrons surrounding this oxygen because hydrogen said that they were going to share with oxygen. And then same way, oxygen is sharing with hydrogen. So now hydrogen doesn't just have 1 electron, it has 2. And then this hydrogen also has 2. So this is done. This is a Lewis dot diagram for water. We're going to talk about in a second why I drew it bent like this instead of drawing it in a straight line, but we'll talk about that later. So let's do one with a double bond. So this is going to be CO2, and carbon, we know, has 4 valence electrons. Oxygen has 6. So I'm going to draw my dots on carbon. Well, let's change it up just for funsies. It's arbitrary which one you choose to do dots and X's for. It doesn't really matter. But I'm going to do X's for carbon, and I'm going to do dots for oxygen. Oh wait, I only need, there we go. Okay, so 6 around oxygen, and then 6 around this oxygen. Perfect. And then I need to find a way to bond it to get to 8. So I see a pair right here. I see an X and a dot that I can pair up and turn into a line. So I'm going to do that. I see another dot and X I can turn into a line. So I'm going to do that. And now I'm going to count, and I'm going to see how many I have surrounding my carbon. I have 1, 2, 3, 4, 5, 6. So I only have 6 electrons surrounding carbon right now. That's not good. I need more than that. If I was to count around oxygen, I still would not have enough. And so I need to find more ways to bond. I see unpaired electrons right here that I could bond. So let's do that. So those that dot and an X can turn into a line, and now we have a double bond. If I count my electrons now, I have 1, 2, 3, 4, 5, 6, 7. That's still not enough. I need another bond to make carbon happy. I see this unpaired electron and this unpaired electron, so a dot and an X, and I can turn that into a bond. So I erase the dot and X, and I create a line. And now I can count. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 surrounding carbon, so carbon's happy. Let's check oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Yay! 1, 2, 3, 4, 5, 6, 7, 8. So all of them are happy. So that's how you can end up with double bonds, is if you bond one time and it's not enough, you might have to go back and do another bond. And that's how you can also end up with triple bonds. So don't forget about triple bonds. That's also an option. Okay, lone pairs, just to let you know what a lone pair is, that's 2 electrons, or 2 electrons make a pair, but they're the electrons that are going to be left over after you do a Lewis dot diagram. And 2 electrons are in a pair, because remember they're in an orbital together, so this is considered 1 lone pair, two lone pairs. So this diagram has 2 lone pairs of electron. This one has 1, 2, 3, 4. So 4 lone pairs of electrons on this one. And that's going to be important later when we talk about the actual shape of these molecules, because these are 2-dimensional structures. We're going to talk about the 3-dimensional molecular shapes that we have. Okay. So some rules when you have to draw it yourself, because up until this point we've just been doing the dots and lines, but when you have to draw your own Lewis dot diagram and put the atoms on there. This is the rules for 3 atoms, if you're given 3 atoms. If O or S is central, then you draw it bent. So that means if O or S is the one that's in the center, then you're going to draw it bent. And we'll talk about how to figure out which one is central. Any other compound with 3 atoms, you can draw them straight. So that's an option. Okay, that's why we ended up with CO2, because C is our central atom, so we draw it straight. O or S, you draw it bent. Anything else, you draw straight. For 4 atoms, so this is pH3, so 1, 2, 3, 4, we had 4 atoms there. You're going to draw it in this orientation, and then for 5 atoms, you're going to draw it in this orientation, just as a general rule to help you. Okay, to figure out central atom, you need to look at the furthest left on the periodic table, except for hydrogen. So when I look at my periodic table, bring it over here, hydrogen is the furthest left on the periodic table. However, hydrogen only needs 2 electrons, so it's never going to be the central atom. So if I'm looking at CO2 and I have to draw CO2 by myself without the template that I've given you, then I need to go look at C and I need to look at O. And whichever one is furthest this direction, furthest left, is going to be the central atom. So C is further left than O. So that's why I drew C in the middle. Same thing over here for H2O. Oxygen is not further left than hydrogen, but like I said, hydrogen's the exception. Hydrogen will never be the central atom, so it has to be O. And there's lots of different ways that we could do this. I think I might have more on the back. Yes, I did. If I have CF4, then that means I look over here and I have C and I have F. And so C is further left, and so it's going to be the atom in the center. You're going to connect everything back to that one. So let's just go ahead and do this one just for fun so we can make sure that we have it. So I'm going to draw my dots and X's around my elements. I'm going to use X's for carbon just for fun. And I have 4 valence electrons around carbon. Fluorine has 7 valence electrons. So I'm going to do 1, 2. And like I said before, the unpaired one I'm going to put towards the atom that I'm trying to bond it to. Same thing here, unpaired electron this direction. Same thing here, unpaired electron that direction. And then almost done. Lots of dots. Okay, and I'm going to look for pairs of dots and X's that I can bond. Here's one. Here's one. Here's one. And here is one. And then I can check my work to make sure I did it right. So carbon has 1, 2, 3, 4, 5, 6, 7, 8. Yay, carbon's happy. And then fluorine has 1, 2, 3, 4, 5, 6, 7, 8. Yay, all the fluorines would have 8 surrounding it. So that's how you do Lewis dot diagrams. I hope that was helpful. And let me know if you have any questions at all. I will do my best to answer them. Have a wonderful, beautiful, incredible, awesome day. Bye.